Creating linear equations from graphs and ordered pairs. So when you're given a graph, the best way to create an equation from it is to use this y equals mx plus b. When you're given a linear graph. So these are the steps you should follow. First, find the vertical intercept. That's that b in the equation. Then find the slope. You can find the slope by choosing any two ordered pairs on the graph and calculating it. And then plug into the slope-intercept form that y equals mx plus b, leaving y as y and x as x. For example, let's consider this graph right here. I want to create an equation for it. So the first thing I'm going to do is find that vertical intercept, and that's 16. The vertical intercept is what is y when x is equal to 0? So here the ordered pair for the vertical intercept is 0, 16. Then I'm going to find the slope. And you can choose any 2 points. I've just arbitrarily chosen the horizontal intercept and the vertical intercept. So I have the two ordered pairs 0, 16 and 4, 0. So remember, the slope is rise over run, or the change in y over the change in x. So the change in y is going to be 16 minus 0 as I move from a to b. And the corresponding change in x is going to be negative 4, 0 minus 4. So I plug into my slope formula, change in y over change in x, and I get 16 over negative 4. I have a slope of negative 4. You can always double check to make sure that your sign is correct. You know that a downward sloping curve should have a negative slope. So now I have the b and I have the m in the y equals mx plus b equation, and I just plug it in. Here I have y is equal to 16 minus 4x. And you can double check your equation. So for example, if x is equal to 2, our equation tells us that y should equal 8. And if we look at our graph, we see that this is true, that the ordered pair 2, 8 exists on this line. So let's go through more of a word problem. While reading a recent journal article on the average relationship between consumption goods and income, you find the authors provide the graph below. The graph shows a scatter plot and a line that's best fitted to the data. You're interested in determining the equation of this line. So let's answer the following questions. Respond to the following statements. Using the graph, create a linear equation showing the relationship between consumption and income. The first thing you want to do when you have a graph like this is define the variables of interest. So we're not working with just x and y here. We actually have two neat variables, income and consumption. Then what we'll answer is, what does the equation predict your consumption will be when your income is $25,000? Then in words, what does this slope tell you? In words, what does the vertical intercept tell you? So let's start to interpret these graphs. So for the first one, we're going to follow those steps. We're going to define our variables. C, I'm going to define as the consumption variable, and Y is going to be the income variable, so C and Y. I do this because I don't want to write out the full term consumption and the full term income in an equation. So now I'm going to find the vertical intercept and the slope. And looking at the graph, I see that the vertical intercept is about $2,500 and the slope is 1/4 or 0.25. You can verify that the slope is 1/4 by choosing any two ordered pairs on the line. I plug these values into my y equals mx plus b equation, and I get that consumption, according to this line, is equal to 2,500 plus 1/4 y. So now I can use the equation. I can use the equation to find out, for example, what consumption is predicted to be for the average person when their income is $25,000. And I chose this number because it's kind of difficult to see what it is on the graph. So when I plug in the values, y is equal to $25,000, I get that income is $87.50, which is right on that line. So now let's start interpreting economic variables. In words, what does this slope tell us? It's not just change in y, change in x. And in words, what does the vertical intercept tell us? So the slope is 1/4. What it tells us is that for every additional dollar of income, people on average spend 25 cents on consumption. That's what this interpretation is. And the vertical intercept is interesting. It tells us at $2,500 that with no income, people will still, on average, spend $2,500 on consumption. So if you've taken macroeconomic courses before, this vertical intercept is known as autonomous consumption. It's something you don't need to know for this class, though. Quiz yourself. So this is the same exact scenario, except the graph's different. So use the graph to create a linear equation showing the relationship between consumption and income. Make sure you define those variables of interest, because we're not just working with X and Y anymore. What does the equation predict the consumption will be if income is 25,000? And in words, what does the slope tell you? And in words, what does the vertical intercept tell you? So pause the video and try this out on your own. All right, so we're given this graph and we need to create an equation from it. So I'm going to start over here, and the first thing I'm going to write out is this y is equal to mx plus b equation. So this is sort of the form that we want to get into. So the first thing that we need to do is define our variables. This y is the dependent variable. It's on the y-axis, right? And this x variable is the independent variable. And that guy's on the x-axis. So what I'm going to do, instead of writing out consumption and income, I'm going to say C, is consumption. I'm not going to spell it out. And Y, I'm going to call income. Some of you may have put I, and that's totally fine so long as you define it so people know what you're talking about. So basically what I'm doing is I'm trying to figure out this. Consumption is some function. It depends somehow on income and an intercept. So the first thing that we're going to do, if you remember, is figure out what the vertical intercept is, this B. So let me just write this out. This is the vertical intercept. So looking at this graph over here, the vertical intercept is where the curve crosses the y-axis, and I see that it's at 2,000. So I already know that my vertical intercept is at 2,000. Perfect. Now I need to figure out the slope. So remember, the slope is going to be the change in y over the change in x. And you can choose any two variables, or I'm sorry, any two ordered pairs that you want. So how about we choose the vertical intercept? Okay, so I'm just going to write this out. I'm going to say that this vertical intercept here is 0, 2,000. And we can choose any point. We could even choose this 5,000, see how nice that lines up. You can choose this 10,000, that lines up nicely. I'm going to choose any. I'm going to choose 20,000. I'm going to choose this ordered pair here. I'm going to say that I'm going to choose this order pair, 20,000, and the y coordinate that corresponds with 20,000 is 6,000. Right? So now I just need to plug in my change in y and my change in x. And I know immediately that my slope should be positive because this guy is upward sloping. So I'm actually going to do this over here. Oh, if it lets me do this. So basically my change in y, let me draw this out. Oops, should be along this line right here. So this is my change in y as I move from A to B. Let's call this A. Call that B. So my change in y is just A to B is going to be 10,000 minus 2,000, which is 8,000. Okay, so remember this is the y value here. So 10,000 minus 2,000. And then as I move from A to B, the change in x is going to be 20,000 minus 0. So 20,000 minus 0. Great. So I can simplify this, right? I can say that, change in x. And this is the change in x is equal to 20,000. Okay. So I can simplify this and I can say, all right, well, I can divide 8,000 and 20,000 by 1,000, right? Which is 8 over 20, but I can even go even further. I can divide by 4 and I get 2 over 5. So my slope is 2 over 5. So I'm going to plug this into here. So now I have let's just make this really explicit here. I've got this C is equal to my plus b. Oh, yep, that's right. And I have my m, I've calculated as 2/5, and I've calculated my b to be 2,000. So my consumption function, based on this line here, is going to be 2,000 plus 2/5 times y. So when I plug anything into this y, if I plug 0 in, I come up with 2,000. If I plug 5,000 in for y, I should come up with 3,000, so on and so forth. So this equation represents this line, or this line represents this equation, however you want to think about it. All right, so I'm going to go ahead and clear this side of the page so we can answer the remaining questions. So we have this function, or this equation, consumption equals 2,000 plus 2/5 y. And the next part of the question asks you, what is C when y equals 25,000? So I can look at this graph. This graph is pretty much set up nicely. So I see that when income is 25,000, that consumption it should equal 7,000, and we can verify this. But the reason we want an equation is because, hey, what if your income is $19,950.33? You can't really see where that is on this graph, but you would be able to plug it into the equation and figure out a number. So anyway, we'll just stick with this because it's fairly straightforward. So if we want to find out this ordered pair, we have 2,000 plus 2/5 times 25,000. So I can simplify, and 2/5 or 40% of 25,000 is going to be 5,000. So we get what we predicted based on the graph. We get consumption is equal to 7,000. So that was that second question. Then the third question asked us, how do you interpret the slope? So the slope is telling us the slope is 2/5, which is equal to 0.4 or 40%, however you want to think about it, 0.4. So the slope is telling us that for every dollar increase in income, people on average will spend, the change, this means change in, consumption is 40 cents. And then the second part of 3 said, what does a vertical intercept tell you? So our vertical intercept is 2,000, so it's saying that even when the average person's income is $0, consumption is still 2,000. And I didn't really write this out in a complete sentence, but I did say it, so we'll count that. All right. So often in economics, you're going to come across curves that look like this. They look like horizontal lines or vertical lines. And the interpretation is that it's showing there's no relationship between y and x, between the dependent variable and the independent variable. So in the graph to the left of the horizontal line, it's saying y is always some number. It doesn't matter what x is, y is fixed. And the graph on the right-hand side, the vertical line, is saying x doesn't depend on y. X is just fixed at some number, regardless of what y is. So the way that I like to think about this is the Hoy versus Vox, H0y. So a horizontal line has a 0 slope, and you can verify that the change in y is equal to 0 on this line. And 0 divided by any number is just equal to 0. So that's the H for horizontal line and 0 for 0 slope, and we write it as y is equal to the vertical intercept. So in this example, the equation for this line is y equals 50. No matter what x is, y is always 50. Now Vox, or Vux, I guess I should say Vux. Vux is a vertical line. It has an undefined slope. All that means is that when you calculate the change in y over change in x, you're going to get a 0 for the denominator. And you can't divide by a 0. So that's why we say it's an undefined slope. So V for vertical, U for undefined. and we write it as x is equal to the horizontal intercept. So in this example, x is equal to 5. Regardless of what y is, y can be 0 or 100, x is always 5. Quiz yourself. Find an equation for each of the following graphs. Pause the video and try this yourself. So the graph on the left-hand side is a horizontal line. Remember, h0y, hoi. Horizontal line has a 0 slope, and the equation is going to be y is equal to whatever the y-intercept is. So in this case, the equation for this horizontal line is y is equal to 8. The graph on the right-hand side is a vertical line. Remember, VUX, V-U-X. A vertical line has an undefined slope because we can't divide by 0. So a vertical line has an undefined slope, and the equation is x equals whatever the x-intercept is. So in this case, x equals 8. Now we can also create an equation when given two ordered pairs, so we don't need a graph to create an equation. What we'll do is first calculate the slope, substitute the slope from 1 and any one of the ordered pairs that we were given into the equation y equals mx plus b, and then we solve for b. So now what we'll have is a value for m and a value for b, and we can plug it into the slope-intercept form. For example, find an equation for the line that passes through 426 and 810. So the first thing we're going to do is calculate the slope. The slope is going to be 26 minus 10 divided by 4 minus 8, and you get negative 4. Now you could have done 10 minus 26 divided by 8 minus 4, and you would still get negative 4. Now we substitute the slope that we calculated, this negative 4, and any one of the ordered pairs, either 426 or 810, into y equals mx plus b, and we solve for b. So I've shown a scenario where we've used both ordered pairs. So for the first ordered pair, 426, we have 26 is equal to negative 4 times 4 plus b. I solve for b and I get b equals 42. I could have used the other ordered pair. I could have used 8 and 10, and I still come up with b equals 42. So it's a good way to check your math. Now we're going to just rewrite our y equals mx plus b, keeping y and x as is, and using our calculated m and b. So we get an equation y is equal to negative 4x plus 42. Quiz yourself. Answer these 3 questions on your own. Find an equation of the line that passes through the coordinates 0, 0 and 10, 10. Then find an equation of the line that passes through the coordinates 15, 1 and 10, 4. And then here's a little word problem. Bobby tells you that at a price of $1, he's willing to buy 5 coffees, and at a price of $3, he's willing to buy only 1 coffee. Find an equation that represents the relationship between coffee and its price for Bobby. So you're given these 2 coordinates. This is for that first question. You're given the coordinates 0, 0 and 10, 10. So we need to find an equation that goes through both of these points. So we're going to, of course, use our y equals mx plus b. Our b is our vertical intercept, m is our slope. So the first thing we want to do is calculate the slope, which is going to be that change in y over change in x. So, if it's helpful to do so, you can label things. So maybe we want to label this as x0, y0, and this guy as x1, y1. So that when we start this out, our change in y is going to be y1 minus y0, x1 minus x0. So it may help you out a little bit if you write this out. So y1 minus y0 is going to be 10 minus 0. And then x1 minus x0 is going to be x1 minus 0, so 10 minus 0. So we come up with a slope, that is a 0, equal to 1. So m is equal to 1. So we know this so far. So basically what you're doing right now is you're building this equation. So what you have is that y is equal to 1x plus b, which can just be written as x plus b. We normally don't write the 1 as the coefficient. All right, so then the next step that we need to do, so this was our first step. So now our second step is to find this vertical intercept. And the reason, or the way that we go ahead and do that is we just plug in values for y and x that we know are ordered pairs. So for example, we can use 0, 0 if we want. I'll do both. So we have 0 is equal to 0 plus b. All right, so that tells us that the vertical intercept is 0, that this line goes through the origin. We could have also used 10, 10. So 10 is equal to 10 plus b, and we come up with b is equal to 0. Same thing, so we double checked ourselves. So now the final step, we're going to rewrite with everything that we know. Y is equal to 1 times x plus that 0. So this equation is y is equal to x. And on this line, these two ordered pairs exist. So now let's go to this second group of ordered pairs that we were given, 15, 1 and 10, 4. So again, we can write this out. If it's going to help us, we can say that this is our x0, y0 ordered pair, and this guy is our x1, y1 ordered pair. So when we go ahead, let's write this out. Y equals mx plus b. The first thing that we're going to do is solve for this slope. So m is going to be that y1 minus y0, so 4 minus 1. And then the change in x, which is going to be x1 minus x0, so 10 minus 15. So we get 3 over negative 5, so negative 3/5 is our slope. So again, what we're doing is this. We just found this out. Right? This is what we have so far. Now we can use the other clues. We've got different ordered pairs for y and x. These are clues to help us figure out what this equation is going to be. So let's go with this ordered pair first. So we can say, oh, that was not correct. So we can say that if y is 1, we know that x is 15. Going to use some algebra here, a little arithmetic. So negative 3 over 5 times 15 is going to be negative 3 times 3. 15 over 5 is 3. So we get 1 is equal to negative 9 plus b. And so we come up with b is equal to 10, and we can double check. We can double check by using the other ordered pair. So we could have said 10, I keep doing that, 4 is equal to negative 3/5 times what? Well, we know that if y is 4, x is 10. We're given this information, plus b. So then when we solve this guy out, we get 4 is equal to, it's going to be negative 3 times 2 plus b, and we can solve this out, and we're going to get the same thing. I know that this is getting a little crammed in there, but this is going to be 4 is equal to negative 6 plus b, so I'm going to add 6 to both sides. Great, so now we have solved, double checked for our b. So now all we're going to do is rewrite it. Y is going to equal to negative 3/5 x plus 10. So, whoops. So this is the equation that satisfies both of these ordered pairs. So now let's go to this final one. We'll go to the next page. All right, so let's write out what we know about this, about these numbers. So we know that when the price is $1, that Bobby or Johnny, I forget his name, demands, he's willing to buy 5 coffees. So maybe you put C for coffees, and that's totally fine. But we also know that if the price rises to $3, he's willing to only buy 1 coffee. So these are just 2 different ordered pairs. So normally when we write an ordered pair, we have the XY here, right? Where X is the independent variable, that explanatory variable, and Y is the dependent variable. So it depends on what X is. All right, so in this scenario, what's what? Well, it seems like how much Johnny or Bobby is willing to buy depends on the price. So the dependent variable is going to be this QD or C, whatever you had, and prices here. So the way that we're gonna write this XY combination is going to be the price and quantity demanded. All right. So I'm just going to move over here for now. So we're told, let's see, these are the two coordinates that were given, P and QD, 1 and 5, and 3 and 1. Great. So what we're doing, you're used to this, y equals mx plus b, but we're introducing some new language, price and quantity demanded. What we're really trying to do here is this. Let's get rid of that. Quantity demanded depends on the price in some way. Okay, so that's it. This is all we're doing. We're just rewriting this in terms of the actual scenario that we're given. So we're still going to follow the same steps. We're going to find this slope, which is going to be that change in y over change in x, which in our new graph, or not our new graph, in this new scenario, is going to be this change in quantity demanded over the change in price. So let's write this out. Let's say that this is P sub 0, and this corresponds to Q sub 0. And this is P sub 1, and it corresponds to Q sub 1. It may make it easier if you write these things out. So we're going to have this. We're going to have 1 minus 5 for the change in Q. So 1 minus 5. And we're going to divide it by that change in P, change in price. It's going to be 3 minus 1. And we get negative 4 over 2, which is negative 2. So we have this slope now of m. So far what we've done is this. We've done QD is equal to negative 2P plus B. What we're doing right now is creating this demand curve. So now I'm going to move over here. Our next step is to use these clues that were given to us about these ordered pairs and solve for B. So I've got QD is equal to negative 2P plus B. I know that when quantity demanded is 5, price is 1. So I can write 5 is equal to negative 2 times 1 plus B. When I solve for B, I get B is equal to 7. I could have used the other ordered pair. I could have told myself, well, I know that when quantity demanded is 1, price is 3. So 1 is equal to negative 2 times 3 plus B, and I get the same thing when I solve for B. So this is a check on our math. So now I'm going to rewrite my equation. I'm going to say quantity demanded is equal to negative 2P plus 7. So there you go. You can go out and ask your friend this scenario, come up with their willingness to purchase at different prices, and come up with their own demand curves.